let's finish off the pole in the barn paradox by doing a space-time diagram, as we've done several times before now. And here's all the calculations we did before. And here's a space-time diagram where the black axes, 90-degree axes, horizontal and vertical, are Bob's barn frame of reference. And we've got meters and nanoseconds, and put the units on there. Here's where the barn is. We're assuming the barn is at x sub b equals 0 and extends to x sub b equals 8. So that's 8 meters there, pretty close to that. And in nanoseconds, 10, 20, 30, 40 nanoseconds, and so on and so forth. We'll get to the green stuff in a minute, but the red is the essentially space-time path, the world line of Alice's pole as she moves through the barn from Bob's perspective. So right here at this point, at t sub b equals 0, the pole is just at the front door of the barn there and goes backwards here 8 meters, because that's how that's the length that Bob sees the pole being. And then as time goes on, when it's at 10 seconds here, it's at not 10 seconds, 10 nanoseconds. It's this position here, and then at 20 it's here, 30 here. In other words, in terms of the space-time world line, it moves this way, which of course physically means it's moving into the barn like that. And then when it reaches this point right here, it's reached the end of the barn there, and of course it fills up the whole barn from one end to the other from Bob's perspective. And note this is at about 44 nanoseconds, just as we had over here, 44.4 nanoseconds is when the photographs were taken by Bob. So he has one clock at each end, one clock here and here, that take the photographs of the end of each end and get the 44.4 nanoseconds. Then what we've done here is put on Alice's frame of reference. We haven't done the whole thing. We've just done the x sub a axis because we're most interested in the lines of simultaneity. We could certainly put on the t sub b axis as well, but then the diagram gets sort of messy. It's hard to see what's going on. So x sub a, you may remember the slope as we calculated it is v over c squared. And using the numbers up here, we get 2 nanoseconds per meter. So that's where we get this line from, and then try to plot it correctly there. So we did that calculation when we first derived how to put one frame of reference on another frame of reference here using the Lorentz transformation. So that's where that comes from. If you're wondering how do I know what angle to put this at, that's the answer right there. And there's a similar calculation we did, of course, for the t sub a axis, which again we'll leave off for this diagram. And so in this case, we have the lines of simultaneity. And I've just drawn parallel lines to the x sub a axis. I haven't tried to figure out exactly the spacing in terms of precise numbers here. But the key thing we can see is as time ticks off here for Alice, okay, so these are like 1 tick, 2 ticks, 3 ticks, 4 ticks, or whatever it happens to be. Right here, at this time, we can see that the barn reaches the end of the pole, or the front of the pole from her perspective, and that's when Bob would take the 44.4 nanosecond picture. But then also, if we look at if we trace the line of simultaneity back here, look where she sees the other end of the pole. It's still well outside the barn. Here's the barn right here, and so it's still back there, just as we did. We erased the picture, but just as we had with the picture of the pole still sticking out the front end, because from her perspective, of course, the pole is 10 meters, the barn is only 6.4 meters. Now, if you did a very precise diagram and put both of Alice's axes on here, you could also show that you get the length contraction effect as well, and in terms of how long she would see the barn being not 8 meters, but actually 6.4 meters there. But again, that gets a little messy in terms of the diagram. But it does show that in our basic combined space-time diagram, you can actually see these effects of the relativity of simultaneity in terms of when the barn doors close here and how far the pole fits in to the barn and so on and so forth. So it essentially is consistent with our quantitative analysis we did before.